Okay, now let's study one concept. For that, consider standard equation of ellipse and one point h comma k, which is lying outside ellipse. So let's draw the schematic diagram. This is ellipse and we have a point h comma k lying outside ellipse. From this point I am drawing two tangents to ellipse. This is point P, this is point of contact Q, and this is R. This point has coordinates h comma k. Okay, now we know how to get equations of tangents. We consider equation of tangent having slope m as y is equal to mx plus root a square m square plus b square. You can also consider minus sign, but we are using this equation to get the slope. And if I take mx to LHS and then square, it doesn't matter, I put here plus or minus sign. Okay, so I am continuing with plus sign. Now this tangent is passing through point h comma k, so I have k minus mh is equal to square root of a square m square plus b square. Squaring both sides and collecting all the terms to one side, I have a quadratic in m, which is h square minus a square m square minus 2hkm plus k square minus b square is equal to 0. Let's check this. By squaring this, we have h square m square. From here we have a square m square. So we have h square minus a square m square. Middle term is minus 2hkm, and we have k square minus b square. We have quadratic in m. We have two roots m1 and m2, which are slopes of this two tangents. Now suppose this angle is theta. I can get value of theta using the formula tan theta is equal to m1 minus m2 upon 1 plus m1 m2. Now from this equation we can get sum of roots m1 plus m2 and product of roots, but here we have m1 minus m2. So what I do, I put this expression modulus of m1 minus m2 as square root of m1 plus m2 whole square minus 4 m1 m2 upon 1 plus m1 m2. Okay, now why I'm doing this? Because there are some problems based on locus, in which we have to find the locus of point P through which angle between tangents is theta. So that time we will be using this mechanism. Okay. Now suppose this angle is 90 degree. Tangents are perpendicular. At that time m1 m2, this product will be minus 1. When the lines are perpendicular, the product of their slopes is minus 1. Now from this equation, what is m1 m2? m1 m2 means product of roots, that is k square minus b square upon h square minus a square is equal to minus 1. So we have k square minus b square is equal to a square minus h square. So we have h square plus k square is equal to a square plus b square. Now there will be infinite points h comma k outside the ellipse through which we can draw perpendicular tangents, and all those points will satisfy this relation. So if I replace here h and k by x and y, I have equation x square plus y square is equal to a square plus b square, which is equation of circle. That means locus of point P through which perpendicular tangents are drawn to the ellipse is circle x square plus y square is equal to a square plus b square, and this circle has a name. This is called director circle. most important circle in ellipse. After auxiliary circle, we have director circle. What is director circle? It is a locus of point through which perpendicular tangents can be drawn to ellipse. Equation is simple. Here we have a square plus b square. So if I consider ellipse 9x square plus 16y square is equal to 144, what will be the equation of director circle? I will be getting this equation in standard form, that is x square upon 16 plus y square upon 9 is equal to 1. So equation of director circle will be x square plus y square is equal to 16 plus 9 is equal to 25. We had director circle in circle chapter. We will have director circle in hyperbola also. In parabola, we have sister of director circle, that is directrix. We know that when tangents are drawn from any point on the directrix in parabola, they are perpendicular, and the resulting chord of contact is focal chord. Okay, now suppose we have one question like this. Find the locus of point P if tan alpha plus tan beta is equal to lambda, where lambda is constant. Now this alpha and beta are inclinations of these tangents with x-axis. The question is, we have to find the locus of point P through which, when tangents are drawn to this ellipse, the inclinations of tangents with the x-axis are alpha and beta such that tan alpha plus tan beta is lambda. We have to find locus of point P. Now tan alpha is actually slope of one tangent, tan beta is slope of other tangent. So we have m1 plus m2 is equal to lambda. How we get the equation of locus? Now m1 plus m2 is sum of roots in this equation, which is equal to 2hk upon h square minus a square is equal to lambda. Okay, so if I replace h and k by x and y, I have locus 2xy is equal to lambda x square minus a square. So this mechanism, this algorithm can be used to find the locus of point P under different conditions, and when this angle is 90 degree, we have director circle. Now let's try some questions on director circle. Question is, find the equation of director circle of this ellipse. We have this ellipse here, center is not origin, so we will write this ellipse in standard form whose center is other than origin. For that, I will segregate the terms like this: 4x square minus 8x plus 9y square minus 36y plus equal to minus 4. I have put some space here. The reason is I want to make a perfect square. So here I must have 4, and here we have 3 square, which is 9. So here we have 3 multiplied by 2, 6. 6 is left. So we must have here 36. That means I am adding actually 4 and 36. That is 40. So I should add 40 on RHS. Okay. Now this is 4 multiplied by x minus 1 square, and this is 9 multiplied by y minus 2 square. You can check. It's correct. Okay, this is equal to 36. Now we divide both sides by 36. So we have x minus 1 square upon 9 plus y minus 2 square upon 4. This is equal to 1. Center of this ellipse is 1, 2. A square is 9 and b square is 4. So equation of director circle will be x minus 1 square plus y minus 2 square is equal to 9 plus 4, that is 13. The radius of director circle is root 13 and center is 1, 2. The center of director circle is same as center of ellipse. ये दोनों concentric है, ellipse and director circle. Even auxiliary circle has also same center. What is equation of auxiliary circle? That is circle described on major axis as a diameter. Center is same. So we have x minus 1 square, y minus 2 square. This is equal to 9. Here we have a is equal to 3. So radius of auxiliary circle will be 3. So we have here 9. This is a director circle and this is auxiliary circle. So you should not get confused between these two circles. Let's try next question. The question is, how many points on the line 2x minus 3y minus 1 is equal to 0 from which two perpendicular tangents can be drawn to ellipse x square upon 16 plus y square upon 9 is equal to 1. Now perpendicular tangents intersect on director circle. The equation of director circle is x square plus y square is equal to 16 plus 9, that is 25. Now we want points on this line from which we can draw two perpendicular tangents, and those points on this line will also lie on this circle. इस लाइन के ऊपर वो पॉइंट्स जहां से हम परपेंडिकुलर टेंजेंट्स ड्रॉ कर सकते हैं वो इस सर्कल के ऊपर भी होंगे. इनफैक्ट इस सर्कल के ऊपर जो सारे पॉइंट्स है वहां से जब भी हम दो टेंजेंट्स ड्रॉ करेंगे वो क्या होंगे, परपेंडिकुलर होंगे. नाउ लेट्स check the position of this line with respect to circle. Whether this line is intersecting the circle in two distinct points, or it is touching the circle, or it is not at all intersecting the circle. For that, I will check the distance of this line from the center of the circle, and I will check whether it is more than radius or less than radius or equal to radius. So distance of this line from center, which is origin, is 0 minus 1 upon square root of 4 plus 9. This is 1 upon root 13. Clearly this is less than radius. Radius of the director circle is 5. That means this line will intersect the circle at two distinct points. And these are those points from where we can draw perpendicular tangents. So answer is 2 points. Okay, now suppose in this question we have here C, and we are asked to find the values of C so that there is no point on this line from where we can draw perpendicular tangents. इस लाइन के ऊपर ऐसा कोई भी पॉइंट नहीं होना चाहिए जहां से इस एलिप्स के जो दो टेंजेंट्स हैं वो परपेंडिकुलर हैं. So again I will find the distance. Here distance will be 0 minus 0 plus c upon root 13, and when line is not intersecting the circle, this distance of center of circle from the line will be more than radius. Okay, so the value of modulus of c is greater than 5 root 30. अगर आप c का वैल्यू ये लेंगे, मॉड्यूलस ऑफ c ग्रेटर देन 5 रूट 13, तो लाइन जो है वो डायरेक्टर सर्कल को इंटरसेक्ट नहीं करेगा. लाइन वॉन्ट मीट डायरेक्टर सर्कल. दैट मीन्स देयर इज नो पॉइंट ऑन दिस लाइन फ्रॉम वेयर वी कैन ड्रॉ टू परपेंडिकुलर टेंजेंट्स. लेट्स मूव टू नेक्स्ट क्वेश्चन. Okay, the question is, find the area of the square in which ellipse x square upon 7 plus 2y square upon 11 is equal to 1 is inscribed. We have a standard ellipse. Equation of ellipse is x square upon 7 plus y square upon 11 upon 2 equal to 1. Okay, so let's start with the diagram. This is ellipse. This ellipse is inscribed in a square. So let's draw the square whose sides are actually tangents to ellipse. So let's try to draw. However, it will be difficult to draw square, exact square. Okay, this is a center of the ellipse, which is origin. It is inscribed in this square. We have to find the area of the square. Now this 4 vertices of the square will lie on the director circle because all these angles are 90-degree angles. So we can find area of the square, or in fact we can find the side of the square from the radius of director circle. This will be radius. Okay, distance of center from one of the vertices of the square. This is O, this is E. Okay. So we get the equation of director circle first. It is x square plus y square is equal to 7 plus 11 upon 2. This is 25 upon 2. So radius OA of director circle is 5 upon root 2. Let's join this vertex to center. Suppose this is point B. So this is also 5 upon root 2. So the side of square is 5 because it will be root 2 times this side. So this side, which is the side of square, is 5 units. So area of the square, area is equal to 25 square units. The concept in this question is ellipse is inscribed in the square and all the vertices of this square will lie on the director circle, and if the circumcircle of this square is given, if its radius is given, we can find its side and hence the area. एक और question try करते हैं. Okay, the question is an ellipse is sliding along the coordinate axis. If the foci of the ellipse are 1, 1 and 3, 3, then find the area of the director circle. So actually coordinate axes are tangents to this ellipse whose foci are 1, 1 and 3, 3. Let's draw the diagram. This is one focus 1, 1. This is another one 3, 3, and ellipses touching both this axis. So we can draw ellipse like this. This point is 1, 1 and this is 3, 3. Suppose this is point A and this is point B. Okay, the center of ellipse will be midpoint of these 2 points, that is 2, 2, which is point C. This is origin. This point will lie on the director circle because these 2 tangents are perpendicular. So point O lies on the director circle. Then what will be the radius of the director circle? क्या होगा इसका radius? This is center of the director circle because center of director circle and ellipse are same. दोनों का center same होगा. So this distance OC is actually radius of the director circle. So AC distance is equal to square root of 4 plus 4, that is 2 root 2. So area of director circle is equal to pi r square, that is 8 pi square units. Very simple question on director circle. बस ये समझना है हमें छोटे छोटे concepts के हमें इसका radius निकालना है and identifying that point O origin lies on the director circle because these 2 tangents are perpendicular. Let's try one question asked in the JEE exam. Okay, question है a tangent to ellipse x square plus 4y square is equal to 4 meets the ellipse x square plus 2y square is equal to 6 at points P and Q. Prove that tangents to ellipse, the second ellipse at P and Q are perpendicular. So let's start from the diagram. We have 2 ellipses, concentric ellipses. Okay, the first ellipse is x square upon 4 plus y square upon 1 is equal to 1, and the second ellipse is x square upon 6 plus y square upon 3 is equal to 1. Clearly this ellipse is bigger one, as values of a and b are more than those of this first ellipse. तो ये जो ellipse है, outer ellipse, it is this one, and inner ellipse is this one. Now we are drawing one tangent to this smaller ellipse. Let's draw tangent. Okay, suppose this is point R. This tangent meets this outer ellipse at points P and Q. Now we are drawing tangents to this outer ellipse at P and Q. So we have these tangents. We have to prove that these tangents are intersecting at right angle. These tangents are perpendicular. Now since these tangents are perpendicular, this point T will lie on director circle of this outer ellipse. T point जो है वो कहाँ पे होगा? इस ellipse के director circle के ऊपर होगा. This point will lie on circle x square plus y square is equal to 6 plus 3 is equal to 9. Now we can draw infinite tangents to this inner ellipse. We will have infinite points P and Q, and we have infinite pair of tangents which are perpendicular. So we will have many points T, in fact infinite points T, which will lie on director circle. That means we have to prove that locus of point T is actually director circle of outer ellipse. We have to get the equation of locus of point T, and if we get equation x square plus y square is equal to 9, we are done. अगर मैं प्रूव करता हूं कि t का जो लोकस है वो ये है जो इस बिगर इलिप्स का डायरेक्टर सर्कल है, तो टेंजेंट्स अपने आप क्या हो जाएंगे? परपेंडिकुलर हो जाएंगे. So now question changes to finding the locus of point T. How we get the locus? Now this R point is variable on the smaller ellipse. So we consider this point as 2 cos theta comma sin theta. कोनिक सेक्शन में अगर हमें कोई भी कर्व के ऊपर वेरिएबल पॉइंट लेना है तो बेस्ट है कि हम क्या कंसीडर करें? पैरामेट्रिक कोऑर्डिनेट्स. What is equation of line PQ which is tangent at point R? We have x upon a multiply by cos theta plus y upon b which is 1 multiply by sin theta is equal to 1. Suppose this is equation number 1. Now line PQ is tangent to the smaller ellipse, but with respect to point T it is actually chord of contact of outer ellipse. ये PQ लाइन जो है वो अलग अलग कर्व के लिए अलग अलग लाइन है, जैसे कि अंदर के इलिप्स के लिए टेंजेंट है और बाहर के इलिप्स के लिए क्या है? chord of contact with respect to point T. We have to find the locus of point T. So let's assume the coordinates to be h comma k. Now with respect to point HK, what is equation of chord of contact? Chord of contact कोनिक सेक्शन में हर जगह एक तरीके से निकाला जाता है. Equation is T is equal to 0. ये T नहीं है, ठीक है ना? This is expression T. Okay. क्या होगा equation? With respect to this ellipse, we have hx plus 2 ky is equal to 6. This is chord of contact. We get chord of contact by replacement method. X square को हमने hx से replace किया, y square को हमने ky से replace किया in this equation of ellipse. Now these two equations represent same straight line PQ. तो क्या करेंगे हम? We compare ratio of coefficient. So we have cos theta upon 2h is equal to sin theta upon 2k is equal to 1 upon 6. Okay, so we have cos theta is equal to h upon 3 and sin theta is equal to k upon 3. So what we do now? We square and add. Squaring and adding, we get h square upon 9 plus k square upon 9 is equal to 1. Replacing h and k by x and y, we get equation of locus as x square plus y square is equal to 9, which was our target. हमें यही लाना था. That means this tangents are perpendicular. तो एक बहुत अच्छा क्वेश्चन है जेई में. इसमें कहीं पे भी डायरेक्टर सर्कल का मैसेज नहीं छुपा हुआ है. जब हमने डायग्राम ड्रॉ किया तब हमें पता चला कि ये पॉइंट तो डायरेक्टर सर्कल के ऊपर होगा. सो वेरी नाइस क्वेश्चन.